Hey everyone, this is Danny from EvolveLAB here at Page for the Denver Dynamo user group. This week we're going to be talking about applied automation with our hosts Corey Green and Daniel Cortez. Let's go check it out.
Hey guys, I'm Daniel Cortez from EvolveLAB. I'm a design technologist doing a lot of cool stuff with MEP and Dynamo.
I'm Corey Green, and I'm the Director of Strategy at EvolveLAB. We're getting ready to do the Denver Dynamo user group this afternoon, and we're going to probably be teaching about 45 people how to work with Dynamo to access Revit's API and apply some automation techniques to documentation and form finding.
And this is where things get really exciting from the MEP and the manufacturing side of things with Dynamo, because all of a sudden you can automate thousands of shop tickets just based on that same logic that each one of them has to be documented with. And that's a really powerful tool that goes beyond just the design space. It's really, really quite remarkable. And I'd say we have more clients coming to us with questions about how to automate for manufacturing from a Revit model than any other stakeholder. Some of the things we get really excited about too, even just like more of that tedious monotony, is how can you use the data that's already in the model? How can we use the rooms to identify what we want to elevate and then write a script that will identify these specific rooms in the model and automatically generate all of your interior elevation views just with one click, right? So this again has nothing to do with computational design or form, but that just cut out about 4 hours worth of someone's work. And those sorts of opportunities are where we're looking to you guys, where if you have any ideas or things that you want to talk about today, it'd be great if I could do this. How would we do that? Or have you seen anything where this has been the resultant? Feel free to add those things. We have a very specific perspective from our backgrounds and expertise, and that's why we have this user group. And it's less of a sort of lecture or presentation format, and why we want to do more of like a teaching and collaborative panel type thing more than anything else. From an interior design perspective, this is the one GIF that will really get people excited in an interior design perspective to actually working with Revit. We found a lot of people are highly capable, but what starts to happen is when you can have the model compare against itself to create things for installation. So you can have cut sheets that you can just put up on the door to indicate exactly what furniture needs to be installed inside of this room. It's just a different way of delivering that looks at how can the data extend our scope beyond what we're traditionally confined to based on the contracts themselves. We're going to talk a little bit too about the resources that are out there. So if you're just learning, how many people here have worked with Dynamo before? It might be a good starting point. Ish a little bit. What about Grasshopper? Cool. You got an exploded pen.
Yeah, I know. Didn't get anywhere else, so don't worry.
So the difference is really in how you can access more of that API, right? The automated programming interface information inside of Revit through Dynamo. And the Dynamo Primer is a great example for where a lot of that information lives. It's dynamobim.org. There's a whole set of instructions and really comprehensive documentation that was built by, I believe, John Pearson. There's also a dictionary of additional, like, I don't know, naming conventions and information that really affects almost on the coding side. Dynamo does have its own unique coding language that they've developed for it, and we'll talk a little bit about that today as well.
And also the dictionary is pretty good when you have a question on what the out-of-the-box notes do. And when you right-click and go to help, it takes you to that dictionary where it gives you like an example of how to utilize that node.
So if you've never started with Dynamo before, great place to start. There's a lot of really good information. Hopefully we can get over the sort of learning curve today so you guys know how to troubleshoot and work with this stuff in the future. All right, so the demo time. This is the fun part. Before we get into this, we're going to show today how to take the grid lines from that example file and automatically place a column at the intersection of the grid itself. So this is a workflow where we're placing instances of an element based on the Dynamo graph and based on the other elements in the model. And then we're also going to show how to take those dimensions, take those grid lines and automatically dimension them. which is, again, a task that happens all the time. But this is a really good entry point. This specific script actually has a lot more going on to it, and hopefully we can cover all of it today. If not, we'll definitely set a way to follow up and document this in a really clean way for everyone. So, only 10 minutes of presentation. We try to keep it really light because these things get super boring, and it's kind of difficult to sell BIM as an idea and Dynamo as an idea to people. So let's just jump straight into it. That makes sense. Any questions so far? Cool. So when you're working with Dynamo, it lives inside of Revit under the Manage tab. And you can see over here on the far right, when you click on Dynamo, it will give you an option that says, well, what version of Dynamo do you want to be working with? And I've already opened up Dynamo 2.0. And this version is a big question, because if I develop a script in 2.0 and want to share it with someone who's only working with 1.3 installed, there will be this major fail point where some of the nodes might have been changed in their syntax, or some of the nodes don't exist anymore, or new nodes have been created that do the exact same thing. So what we do when we're developing these scripts is we're trying to be really specific in naming conventions for what it is that you're working with. So in this case, I've already written this script, which we'll hand out at the very end. We're going to walk you through this example of how to build this script, and then we'll kind of go on to the next one as well. But the important thing that I wanted to point out early on is that when you're working with scripts, it's a really good practice to indicate in the name what version you built it in. And so this is our technique that we've dealt with for it, where this is called the auto column placement, so you understand what it does. And then we do a parentheses Dynamo 2.0. That way, if there's a user that doesn't know Revit or Dynamo at all, and they just want to work with this thing, they can open it up and start to work in the right software. If you wanted to switch to 1.3 in my scenario.
Sorry, and to go back to that naming convention, also if you're working with packages, you also want to specify what packages you're using in the naming convention. That's going to be really helpful when you're giving it to somebody else so they can know exactly where to put those nodes.
Right, so to expand on that further, the way Grasshopper has such a strong open source set of add-ins to it, or extensions on top of it, Dynamo has the same thing, they just refer to them as packages. The package library or the package manager is right up here, where you can search for a package. And one of the ones that everyone likes to download and use, a huge advocate of it, it's a great piece of software, is called Dynamo. You might download that actually specifically from his own website. That's Nate Miller Improving Grounds package. And then there are some other ones that are great ones out there like Clockwork. So you just kind of type it in and you can see it comes up here. And all you have to do is click to install the latest version. Once that's been sort of, maybe you have a node that's coming from, we have our own package, which maybe I should advocate for too. So we have our own package, and if I were to use that node inside of a script, I would indicate in some way that this is in fact coming from the EvolveLAB package. And we'll show you guys how to do this later on. But in addition to articulating it inside of this group, we would do a file save as and describe it in terms of this file naming convention. So someone knows exactly what it is that they need to work with this script. So has everyone here sort of been exposed to what a visual program is and how this differs from writing code itself, line by line? In the Dynamo environment, you have a whole set of, essentially you have a canvas that you can write your scripts within, and then you have a set of nodes that you can visually go through this list and say, okay, well, I want to see what options there are for inside of Revit to manipulate an element based on maybe its coordinates. Right? So this is the sort of logic that they have built their icons or their nodes from. And each one of these nodes will create or will command the software to do a slightly different task. And you can kind of see what we have set up to start off, which is a really basic task. How can you add two lists of information to each other? In Dynamo, you have the ability to create what's referred to as a code block. And we can articulate things differently versus a string by identifying its parentheses, or excuse me, its quotations before and after. Or in the case of what we're seeing up here, an integer, which is something that's just like a 0 item, or a float, which is introduced as like a 1.5, right? So you can itemize those sorts of objects really differently, and when you connect them to each other, they start to create a different result, where I can create a series of letters from A to D using the specific syntax. And again, to create that code block, I'm double-clicking in the canvas, and I use these all the time to create quick strings and objects, numbers, integers, things like that. And at the end of the line, you'll see I do a semicolon, and that will indicate that there's some output from that row. So how would I maybe add the number 1 with the other number, 20.5? So we can do this by creating a code block, a line for each one of those, and then searching to see, well, what options for addition does Dynamo have as an operator? Where we might just want to be doing a basic mathematic addition, and that's where you're seeing that node come up here. And you can start to add these together using these specific nodes. And you'll see there's something really nuanced going on in my script here. I have this set to manual. If you're developing a script for someone else's use, it's really important that you set that value to manual. Because what will happen when they open your script for the first time and it's set to automatic is it will start running. And if it's a really complicated script, that could throw some really big issues. So not knowing where everyone's at in the room as far as skill levels, I wanted to introduce these basic concepts because we'll be building out on top of this as things get more and more complicated. So something really nuanced here is happening. You're seeing that that value is now 21.5 after I click run. I can also associate that instead with a string, where I maybe want to say one string and add them together. And you'll see what happens. So Dynamo is fairly intelligent. It knows when it's trying to do a mathematical addition, or in this case, a concatenation of two different strings themselves. And it understands that difference between, so if I were to call this, I'll add another line, and I were to just type in my name, right? This is a string, right? Well, that would actually be declaring an input variable. So there are slight differences in how we're working with these, and we'll get into that some more later on. Any questions so far? Okay. So one of the things, and this is a little bit more of an advanced concept I just wanted to document for the sake of the recording and later on, is how can you create series? In Grasshopper, there's a really great way to create a series that starts at 0 and goes to some end determinant. In Dynamo, it relies on a range, which is just incredibly cumbersome to start to think about every single time. However, what you're seeing here is I'm creating the same behavior of a range by indicating that I want a start value of 0, maybe an end value of 10, and I want it to step in increments of 1. And now when I run that script, you'll see it will go from 0 to 10 in increments of 1. And the nuance here is that because this is a 0-based environment, you're actually seeing 11 items show up in this list. Right? So that's why things are a little bit confusing, because it's just counting from 0 to 10. Well, 0 counts as a number. So when you're looking through your scripts and you're seeing, okay, well, how many items are actually in this list, which is being indicated here, or in this case, this list has 44 elements, you can start to expand or contract the sort of pin icon that gives you an insight to those data points. And this is one way of creating a range. Another way that we're implementing up here is starting from 0, space, or period, 10. That same set of instructions will create a range from 0 to 10, just the same as this node here. So as we're building really complex scripts, code blocks are really powerful because they can let you accomplish in a few specific instructions here, or formulaic exchanges here, the same that would take 2 nodes, which when you do 500 nodes, you can cut that in half. All of a sudden, you can troubleshoot it a little bit more effectively. So if you guys want to create some code blocks, we're going to maybe replicate this first step, where we're just going to create an addition, and we're going to talk about 0.5. So the syntax for that is fairly similar. It's 0, point 10, I believe it's hashtag 0.5, or pound. Now when I run that, obviously it's going to create an issue here. You might not even need that. You don't even need the pound sign.
Oh, okay.
So this is start to end in your step. And so one of the things that you're kind of realizing is that Dynamo has this ability to take outputs from one node and input it really clearly into another. Whereas Grasshopper, you could actually have multiple nodes input into one, right? Multiple outputs could go into one input. That's not the same inside of Dynamo. And so what we're trying to do is just connect this one-to-one relationship. You can have multiple outputs from one part of the code block or one node, but you can only have one input into that portion. So the question that's coming up is, well, my output probably looks something like this, where it's taking the first item in my top list and adding it to the first item in my middle list, and so on and so forth. So that's a result of what's referred to as lacing inside of Grasshopper. It's the same concept inside of Dynamo, though we actually have a little bit more control over that than previously. So as we go through, you can right-click on this icon here and say, well, I actually want to compare these two lists. And I use the example of, if you think of a meeting of two different companies, one person might have 3 people show up from another firm, and one person might have 7 show up from the last firm. Everyone goes to introduce themselves, so they shake hands. Well, 4 people get left out, or that last person has to shake 4 hands. So that's kind of the idea here with lacing, which is how do we get lists to match each other up? And in this specific example, we're using a cross product. And as we get more into today, we'll start to articulate that more clearly. But we want to set this to cross product, and you'll see what happens. Is it will then have every item shake each other's hand and create that much more robust list. And so why do we really care about that? Because if I know at a certain point I want a specific element out of a list, maybe it's the first or second or 3000th, I don't know exactly. But how do I start to articulate, well, I want to isolate only the second item from all those lists? And you can see what we have is a node referred to as list.getItemAtIndex. And I might see if there's a place where I can identify in my toolbar that list. And let's see if I can inspect a list to get my item at a specific index. And what that will allow us to do is take this really long list of 44 things and isolate only the second item. And you're seeing something that I've kind of cheated a little bit in here. I've already changed the setting. If I change this so it selects item 2, well, it gives me actually 11 elements, not 1. And so the question is, what's the reason for that? What's the logic behind that? So if I were to expand this, and you can kind of see in my drop down here, I can expand with my left and right keyboard keys to look at the nesting structure, is we're actually able to identify, like, really specifically that the output of this entire node is 44 items that have 3 different layers of nesting. And this specific node is asking for only what's at that very second item, which would be 0, 1. And then I guess that this one is asking for the 2 index. So it's not pulling my second item or my third item here. It's actually pulling from this top level list. And that's a really nuanced thing about list levels, where in this scenario I'm getting everything
that's at index 2. And you can see this idea of nesting where there's this line that says, okay, well, this is level 3.
This is level 2. And everything down here is at level 1 of the nest. So how would I, for example, get every second element from all of the lists? And that's where, if we see this triangular arrow at the end, I can say that, well, I want to select every index value 2 in the entire list. And of course, that doesn't work. As I cycle up, we can see what happens. That gives me, right, different information depending on what level we're associated with. And again, that's pulling the second value from every list at level 2. Whoops. You can see, so this is the third level. This is a second level. It's pulling that A2 value as well as the C2 value at each one. So that's a really basic introduction to the way lists and the logic around that works inside of inside of Dynamo. Daniel, do you have anything else you wanted to add? Yep. So now that we've got that basic understanding of the way the data flows through the model, Daniel's going to step in and talk about how to actually consume those elements from the model and how to navigate a little bit more so we can work with this information.
All right, so for this particular script, we want to automate the column placement at the intersection of these grid lines. So the first thing you want to do when you're writing a Dynamo script is you first want to identify what your end result is going to be like. So for this example, we have this out-of-the-box node for family instance by point and level. So if you type it in, it's actually going to be a out-of-the-box node. So if you hover over it, it's going to tell you what your inputs are going to be. So you're going to need the family that you want to place. You're going to need a point, and you're going to need a level. So when you place it in, then you want to place a family type node that is going to give you all the families that are available in this particular project. So for this example, we're going to do the concrete round column at 600 mm. And then we're going to need a node that is going to tell you at what level we're going to place our column. So this example, I think it has 3 levels. So we want to make sure that we're specifying which level we're going to put those columns at. So now that we have our, what's that?
What was that family type again? Started with an M?
Yeah, so it's going to be the M concrete round column.
It doesn't matter which of the sizes.
No, it doesn't matter. Yeah, this is just an example that we're going to try to put those columns at the intersection point.
And the model that you have currently, the default one that you opened, has those columns already placed. And that's why we're able to choose them from the dropdown. So what Daniel was just articulating was the general logic for how a Dynamo script works. Typically, we want to bring some information in, think about that information or process it, and then create an action based on that. In this case, we're trying to bring in all the grid lines. We want to identify how they intersect each other, and then the action is to place a column in the model environment outside of the Dynamo interface.
Right. So now that we have our family instance node in there, the next thing we want to do is bring some nodes to bring those elements into Dynamo. So we're going to use the categories node. So right now we have these frozen. So if we unfreeze them,
you can freeze and unfreeze things. For example, parts of a script that you're testing, you don't want it to run all the way through. You can freeze it. So by right-clicking on it, you have the option to freeze an element, and that will allow you to basically stop the computation from happening past that point.
Yeah. So it's going to be that dash lines when it's frozen.
So the nodes that we're looking for here, you can kind of type these into the search bar, or you can right-click in the canvas and search for the node just by right-clicking on it, and you'll see what comes up.
Right, so you can either search it here in the library, or you can right-click and search for your nodes.
And what we know here is that we're trying to work with the category of elements for grids. So there are going to be your other Revit categories. You're going to have walls, floors, every other sort of object type that there is in the model will be available from that dropdown. But what Daniel's done is he's found that categories selector, and he's selected from that dropdown the specific grids that we want to work with.
Right. So once we have those categories of grids, now we convert them into the elements of those categories. So now it's showing that we have 22 grids.
Do you have to copy monitor, or is it just fine?
In this model. So now we want to extract that geometry of the curve. So we have our elements, and it's going to convert it into your curves. And now we go and find a node for the geometry intersects. So what this is doing, it's finding those coordinates of the lines. And now we want to run it so it finds those intersection points.
So can you go full screen again for a second? So I think there's one point that I also want to make here too. That's when we're expanding these things out, we'll hover on this for a minute to sort of explain what's happening. The second node, all elements of category, is basically, think of it like a schedule, where you're creating a view schedule just for grids. And what it's actually bringing in isn't the center line. It's not the geometry. It's the actual Revit object. And that's what you're seeing where it says 1, 3, 7, 6, 7, 8. That's the true object, where if you were to go under your Manage tab and select by ID and type in that exact number, that's what it's indicating. So as we're working through this, one of the challenges is the geometry itself has to be extracted from the object. So it's one thing to bring the object in as the Revit ID. And then the third node is we'll take that grid line and extract its underlying curvature. That way we can start to compare these curves for what we're typically used to, which would be a geometric intersection. And that's really the sort of key first couple steps that happen on pretty much every script you're working with, where you'll be taking something in from the model and either identifying its boundaries of a room or its center point or insertion point of a chair family, identifying something about its location, which would be grid.curve in this example, its underlying geometry. Another one that's really frequently used is element.geometry. So that's just like the namespace for this stuff is a little bit weird. And element.geometry will take whatever element is in the model and extract out its base geometry. And so you can see how it's asking for an input of element, and that aligns exactly with the output from all elements of category. So those two nodes are really, really powerful in connection with each other, and it will help you navigate what you're consuming really effectively.
Right, so now that we're mining this data, so we have our coordinates of the line for the end and start and end point, as well as the length. Another thing to notice is if you right click and you click under preview,
Stop walking in front of my camera.
you can start to see those elements that are being brought in. So now that we have our lines and we find those intersection points, we want to filter those points out to make sure that we bring in those exact points that are going to allow us to place those columns in. So what this is doing is we have our filter by list node that is going to give us those intersection points in the model. So now we can go ahead and when we run it, it's going to place those columns where we have the intersection points.
Could you go back to the previous green box and show that for a little while?
Yeah.
Yeah.
So we found our intersection points.
And the way we're doing that is we're comparing one. You can kind of see the logic in the inputs here. Is we're extracting that curve geometry. And to find an intersection, you have to compare one curve against another. But in this case, we have to do something really specific with the list lacing here, where we switched it to cross product. Because to find the intersection of one grid, we have to compare it against every one. So this goes back to the idea of you want these two lists to kind of compare each other equally, which is why we have the output of one node plugging into the same or different inputs of another node and comparing against itself. And there might be other more effective ways of doing this, but as we're teaching, this is a really helpful tool to understand the consequence of what happens when you switch from the right or wrong lacing structures. So if you're getting to this point where you found your geometry.intersect, which might be up here under the geometry, and then what we're looking for is probably some sort of curve. And then in here, it's somewhere in here, it's a curve intersection. And we're trying to compare these things against itself. And if it's not under curve, it's probably... My eyes aren't that good, but it's somewhere. So you can also just type it in at the top of the search bar as geometry.intersect. So think of this too in terms of Rhino, like you would Boolean two objects to compare them against each other. That's the node that we're looking for, where it allows one object to be compared. It doesn't have to be grid lines. It doesn't have to be curves. It can also be surfaces, where you might be doing this sort of comparison. So as you're coming out of that node, you want to be sure to right-click and set your lacing to cross-product. And again, this goes back to one of the reasons why it's hard to troubleshoot in a Dynamo environment, is because if I didn't point that out to you, and you were looking at this from 10,000 feet, or aside from this really sensitive mouse, if you were looking at it from the whole overview of the script, you wouldn't have noticed that. So there aren't really good ways to communicate this, and it's just something to pay particular attention to when you're trying to troubleshoot. My first question is almost always, is my list lacing and are my levels set correctly? And I wish there was a better example. There are some really good primers online that deconstruct it more than we got to in the first couple nodes. The unfortunate answer for me is I do a lot of testing and checking, and testing and checking, and testing and checking, where I'll go through and I'll switch these values out. Well, is it right if it's shortest? Is it correct if it's longest? Is it correct if it's cross product? And then I'll just run every one of those times. And so the output that we're getting from there is going to be a combination of the lines that intersect, the points that intersect, and a bunch of empty values. And that's one of the challenges too, is, well, how do we identify just the points? Because there's kind of like the strings are one object, floats are another object, integers are another object. Surfaces, points, lines, they all are articulated a little bit differently. So as we look through our output, you can see we have some empty lists, we have some lines, we have some points. And there's probably a smarter way to get to this. But what I like to do is I also will sometimes just translate that object into a string. because strings are really easy to work with sometimes. And if I know that every point in that list is going to be called a point, well, I can start to do some string comparisons rather than having to do this really complicated mathematical equation to isolate what's a point versus a line. And so that's what we're seeing as the output from here. Sometimes you have to convert objects back to a string, or sometimes you have to convert strings back to an object. And you can find that node by right-clicking and just typing in exactly how it looks, string from object. And if you're trying to sort of really see what you can or can't do in a model, searching the sort of object bar or the toolbar, whatever you want to call it, is a really helpful way of seeing what commands are available with the specific items that you want to work with. And so that's what we're doing, is we're taking that string and extracting it from that really complicated, it's a line, it's got a start point this and an end point that. And we're converting all those to characters that we can then compare. What's the substring? What are the first 5 elements that will indicate something about the element that we're trying to manipulate? And in this case, it will return that it's a line. And again, we're indicating the start index, which is item 0, the length, which is 5, and we're allowing that to do a comparison, where once we have that string identified, we can compare it back to anything that we know is going to be a quote point, right? Again, I'm not calling it unquote point. That would declare it as a variable. I'm actually referring to the string as quote point quote. And this is what's referred to as a operator for comparison that will help us create a true value list that we can then filter or do a cull in Grasshopper language. In Dynamo world, they call it a filter by Boolean mask. Making sense? Working? So in your case, you actually want specific capitalization matters, because it's going to look for exactly what you have and compare it to what's there. And so what we'll do is we'll zoom in a little bit more, so you can see once we so far. You got sure. So that's actually the next point that we're going to talk about, which is how to move information around a script. Questions so far? Yes, no? Okay. Questions so far? Nice. Questions? Cool. Okay. So we'll get into that. I'm guessing from object, comparing it. That probably needs to be capitalized. Questions? Cool. Yeah, thanks. So the next step as to what ends up being processed, which is, well, what input here has to come from further upstream, where we're trying to find that insertion point, right? So here's where we'll go upstream and we'll see that we're identifying the intersections and we're trying to push that forward into the next set of nodes. For this example, I was zoomed in really closely, but we don't know what this input is. And occasionally what I'll like to do if I have a really long or large script is I'll place a code block and I'll define a variable. Let's just call it intersection geometries. And you'll see that allows me to create an input that I can then funnel from somewhere else in the list. Where when you're trying to work collaboratively, it's really helpful to use this just as a pass-through so you can know what's being input into the next node. More specifically, if we wanted to have this occur elsewhere in the model, I would just make that association early on, and then if it happens way further down the script, you'll see again what it is that you're working with. That's one way to create that continuous relationship upstream and downstream so that your team members can know what it is that you're doing.
What did you call that? Like just a...
This is a code block.
But so it's just...
And I'm just using it as like a pass-through.
Pass-through.
That way you can sort of define the name that you want that pass-through to be called, and I could call this like points, right? So it's bad practice to use something that Dynamo is going to try and fill in automatically for you, which is why it helps to start off, which is like, underscore points passed, right? So you can use different syntax, and this one's probably going to not work, because what you're doing is defining essentially an input to that code block and just passing it through to the next icon.
With the watch notes.
Right, and so Daniel makes a really good point that we talked about earlier, which is similar to how Grasshopper you can watch things in 3D as to what's going on. In Dynamo you can watch in 3D or in the 2D itself, so you can actually type in a watch node, and this will only visualize what's kind of coming out of your script. So that will all it will do is basically make a permanent fixture for the same drop down here. So one thing that you might have noticed by accident or intentionally is that Dynamo has a canvas. You can switch between what's navigating in this canvas view or up here at the top right, which is under the, let me pull this a little bit. You can see the canvas view versus the graph view here. Where if I want to see the 3D geometry, I can zoom in and out and you'll see your 3D geometry is actually hovering in the background. And you can use your pan to start to push that up into the corner. That way when you're working in your graph, it's not in the way of the line work that we're manipulating.
The Revit family is going to show up in the Dynamo preview.
Correct. And as we're probably going to see, I bet I've placed 3 or 4 of these on top of themselves by now. But all that's coming in at this point are those geometries, those underlying curves, intersections, those points. If it was a surface, it'd have a surface geometry. And what we want to do is start to identify those points that we're filtering out here, where that mask that it's taking is anything that's a false is going to go to the out, and anything that's a true is going to go to the in. That allows you to separate out and bifurcate your data so that we can then assign, like Daniel talked about early on, the family instance by point and level. And again, if you look under some of the Revit, let's go under Revit selection. You can see all the different choices we have for selecting and bringing elements into the Dynamo graph. In this case, the node is family types. And that's just looking for the type of column that we were working with. And if you had loaded in an adaptive component, it'd show up in this list. If you loaded in a handrail, you can see essentially every one of the family types in the model environment is available in here. And that's where you have your option to create that 300 millimeter column, whatever it might be. You have to assign that as your family type. And then let's see, what about levels? Because we want to be able to choose levels from a drop-down. You can see again, you have an option here in the under Revit selection to choose your drop-down for levels. That will allow you to place that family element at the point on that specific level. And when you hit run, it should automatically instantiate either nothing or something at those intersections. And then you can see them in your model environment again. Whoops. So is this zoomed out enough for everyone to kind of see the last couple steps? Yeah, so I'll be sure to sort of take that 30,000 foot perspective on it, and then we'll work backward to make sure that we can at least understand why these things are grouped in specific ways, and showing that this actually does in fact work. So when we're building scripts, a lot of the times I'll either start at the end or at the beginning. Depending on what your preference is and what you know that you're going to be working with, what is something you can rely on. In this example, I know I can rely on, again, we have that set of things that we're choosing and pulling in. I can rely on my grids, and I know that I want to take those grids and ultimately I want to create a dimension to them. Right? And so if this is our endpoint, we either have to figure out how to reverse backward into identifying the view that we want to be working in, the elements that we want to be dimensioning. The line here refers to the sort of actual dimension string, the location of the string object. And I know I want to do that maybe, for example, for the left part of the plan and the bottom part of the plan. And again, Daniel and I have been going back and forth and building this last week, so I don't want to be sort of pretending that this is just the result of me knowing Dynamo that great. Everything we do in Dynamo is really collaborative, and that's why we try to break it up into these sort of meaningful chunks, where I can identify that this is going to be the portion that actually creates the dimension string. And I've made the mistake here of not titling my groups. To create a group, again, when I've finished building my script, a lot of the times I'll clean it up after the fact. You can create these groups of nodes by selecting 2 of them, and then if you hit Control-G, it will create a group. You can change the color and the text, things like that start to communicate a little bit more clearly. I thought we had already named all this stuff, so let me just double check. This looks like it's correct. Well, it looks like it's the right file, but not correctly named. So with that sort of understood that that's our end goal, how do I segment this up into these coherent steps? And you're seeing up here, this part of the script is actually what we just completed. So I built these as one sort of consistent script. For now, I'm just going to delete this because it's distracting. And I'm going to ask myself, well, how do I funnel this information, right? These curve lines, and start to identify where my dimension string needs to live. So I need to be able to evaluate this curve of the curvature of the grid. And I'm gonna freeze some of this stuff later on. So let's freeze the node right here. And you'll see when I freeze that, everything else downstream will lock up. I want to identify the start and end points of each one of these structural grids, because that will start to tell me where my dimension string should sit in plan. And that's thinking a little bit, maybe running into an issue or two. But again, these grid lines, we know that that's where the start point and end point of our string needs to behave. So we have to identify somewhere along column line J and go all the way up to A, and then somewhere along column line 1 and go all the way out to 8 or 9, whatever it is. So how do we start to extract those information points from our grid lines? The logic here is let's take those curves and identify the start points and end points of all of them. And once we have those start and end points, we can kind of create what looks like, here we go.
Okay.
Okay. So I'm going to switch over to our one that's been marked up better already. Where's that?
DDUG.
Okay. So we already went through this exercise of naming stuff we did in fact prepare. So we want to identify where the endpoints of that column line are. And again, I'll run this by freezing my end part. And this will give me that list of points. And these points we know will start to orient our dimension string. I shouldn't be looking at that. So as I zoom out, again, I'm going to look at my model environment, and you can see where all the endpoints of each one of those grid lines is. We want to join those together because we don't really care to know which grid line is what. What we want to identify is the lowest x value and the lowest y value, as well as the highest y value and the highest x value. and then create a line that connects those points so we can create our dimension string along that line. And so essentially what this script happens to do after this point is we take that list of points and we isolate what's on the bottom part of the plan, which is going to be these points. I'm going to preview this. And you're going to see they're all kind of going to be on top of each other here as I run this. Right, so you'll see this funnels through and identifies the points that are on the bottom of the plan. And you can kind of see them faintly turn to blue in the background versus the points that are at the top part of the plan or the left part of the plan. And so one of the things that's a little bit tough to see is these previews. Things will start to be sort of turned on and off multiple times in the project. If you right-click on it, you can unpreview items, and that will give you just better clarity as to what it is that you're working with at that point in the graph. So I'm going to turn off a couple of these previews to give us a more clear articulation of what it is that we're looking at. So I only want to see what the points are at the left side and the bottom part, because that's where my dimension string needs to run along. So as we go through that isolation, what I'm looking for is the x value. And I'm isolating what the smallest one of those x values is by using this math.floor. So coming out of this master list of all the points, I'm evaluating the point.x. And think of this in terms of like the Cartesian coordinates. You have an x, a y, and a z. Point.x or point.y will allow you to identify the specific x component or y value or z value. And this will help us understand, well, anything with the lowest x value, right? So what's the lowest x value, which is obviously, this must be in millimeters or something, pulls that true-false list and isolates just the individuals that are along the left and bottom sides. So we do that not just for the point.x, we're also doing that for the point.y, because we want to isolate out the left side versus the bottom side. That will then articulate which grids it needs to be dimensioning to. So this next batch of nodes will start to create this actual line itself. And you can see there's a few steps in here that are a little bit goofy that we'll talk through once I've kind of given the high-level look at this. That I'm identifying these points, sorting them by some logic, and then creating a line that isolates the first point and the last point of that logic. That line then becomes my basis for the dimension string. And I want to compare that line to all of the elements that are either the grid elements that are facing vertical or horizontal along the x-axis or y-axis. And so you can see the elements by category that I'm pulling in here. These are the grid elements. And what we're doing is we're checking to see what's parallel to each other. And this filter will help us identify all of the grids that are parallel in one direction and all the grids that are parallel in another direction. Once those have been identified, you can then differentiate between, well, what grid lines need to be associated with this top dimension string versus this bottom dimension string. And I'm just going to freeze this one, but I'll leave the other one active. And when I run that script, you should see in my plan, sorry if I'm jumping around, you should see in my plan this crazy located dimension string. You can control the location of this, though admittedly we ran into bugs while trying to do that this morning. But even so, this is still a heck of a lot better than having to manually place those. And so that's kind of that general logic, and you're seeing that blue ghost here, where there's the dot, which is the point, and the blue line, which is the location line that dimension string should be getting placed at. Should being the operative word. It's not working for whatever reason. Maybe that's a Dynamo 2.0 or a 1.3 thing. So I will see if there are any specific questions you guys had. Otherwise, I'll walk through the exact logic for each one of these steps in a much more involved way. Questions? Yes, no?
What do you think was triggering the
the implementation of the dimension string to shift off of what you would expect?
I honestly have no idea. We were trying it earlier on his machine when he finished writing the script, and it worked perfectly. We could shift it, for example, 10 feet in from the head of the bubble, right? And that's what we would want to do. We would want to have that level of graphical control. All that would change is whether or not this line is being manipulated. And specifically, you can see that we've, maybe 3 isn't the right amount. Maybe if I change this value to be 300 and 300, we'll be able to see that happening at least, right? So we can move it one way or another. And let's add another 0 to that so we can really see it. So we can manipulate the location of that line, and we would have that sort of then funnel up here or there. But when we tried that, it just didn't work, period. So there's no reason to use this set of grouping elements. But I just don't know.
Okay.
And that's some of the issues when people say, oh, Dynamo's not really stable. Well, what do they mean? It's doing exactly what you think it should be doing, but it's not doing it perfectly. So that's that sort of nuanced conversation. So if we kind of keep digging into this, I think Angela, you had a question too.
Just at a general level, so if you had a high rise and you have 50 plans and you want to dimension all the grid lines, how smart is Dynamo, or how adaptive is it if you delete one of those grid lines, or if you add a new one and it has new
right?
Does that break the whole thing, or can it?
So every time we run the script, it reinserts every dimension string that's there. And that's actually a really good question in regard to like the columns themselves. So if you don't want one of those columns to show up for whatever reason, you keep running that script, maybe your engineer says, you know what, you don't need one at this intersection. You'd have to figure out a way to isolate that one column and tell the script not to place it there. So rather than deleting it, you actually have to control it in the data flow to exclude that one item. And that's where that Boolean mask logic, that filtering, is helpful. You might say, at the intersection of grid line A1, don't place a column. You'll create a filter that skips over that step. Otherwise, it's going to recreate that column every single time.
That brings up an issue with a lot of these just scripts that generate stuff, right? And I think a number of these examples can be preemptively correct, or like avoided, these issues where you would have generation upon generation.
Right.
If you first have part of a script that exports out element IDs, and then your second script reads those element IDs and checks them before it does something to them. So in that case, you would once you close Dynamo, it's no longer connected unless there's an element ID to connect the script to the file. So
double check it before you apply it.
Yeah. We've done some scripts like that. The guy, Chris, are you still on the phone?
Yeah, I think we kind of turned his volume way down. I'm not sure if he's listening.
Yeah.
That's all right.
We were getting
I
too many back.
can explain it. But Chris has done some stuff like that for us, where we have bi-directional, communication between Revit and Excel and back and forth.
Just to make sure that things that are being placed and things that shouldn't be are being maintained.
Right.
Yeah. Just
connecting data and avoiding over creating the same content right on top of itself.
Yep. So I'm just going to dig into the very specifics again, what we're doing. It's that base idea. We have to bring something from the model to start to manipulate back into the model later on. So we're consuming those grids, every element of a grid. We're extracting its curve geometry, again, because this is going to give us a bunch of Revit element IDs. And what we need to then do is extract the curvature from those grids so we can identify not the intersection this time, but the bottom left and the bottom, I guess the bottom left is a corner. I shouldn't say the bottom points and the left side points. Once we identify all of the start points, again, the reason why we're identifying start points and end points, because the orientation matters inside of Revit. If you place a column over on the left and drag to the right, it has a different orientation than if you click right and drag to the left. So rather than assuming that everyone has modeled columns how I would model a column, we're collecting both the start and end points, then looking at the data to identify what's the far left side and what's the bottom side. It's the same thing with walls. Walls have a start point and an end point as well as an orientation. So it's a really helpful best practice in how do you sort of look past the human error that could happen and just rely on the information so that we know we have to isolate everything based on its X value. And what we're doing is we're creating all those points by curve.startPoint. This is kind of an evaluation of a curve where we can go, I think it's under geometry, curves, and then you can identify the start and end points somewhere in here. Again, I would just type in start point and see what comes up. So in addition to those start and end points, we're identifying that as a separate list where we're only looking at the X values. This will help us identify, if this is our X-axis, which points are on that X-axis. Right, and that's where we can take this list of values here and look at just the math behind it. And floor will basically round down to the nearest whole number. Ceiling is going to do the reverse of that, where like math.ceiling is going to round up to the next largest number. And inside that overall list of integers now, we can extract the minimum value. And a good example of this is maybe you're trying to find the smallest window opening on a project, right? Where you might take that area, get this whole list of all the surface areas of all the windows, and extract the minimum item. What we can do is use that as a comparison to create a filter here, where what I want in this true-false list is anything that's equal to negative 17,000, which is going to identify these set of points. I want that to be isolated separately, right? And that will be how I take my point list, and I'll filter by that true-false, and anything that's equal to true will become my output for those points. And we would just reflect that same logic, but instead of evaluating the X of that point initially here, we'd evaluate point.y. And you can see there's redundancy where everything from this chunk of nodes is doing the exact same thing. There is a better way to manage this with lists, but for now we just kind of wanted to introduce you to the concept of, well, if you have to do something on one edge, you can basically take this group, and I think you can do a Control-C, Control-V, and copy and paste it, and it will actually bring all the nodes with it. I'm going to delete that because we don't need it. Also, if I wanted to copy and paste, I could hold the Control button while sitting on top of one of the nodes. It will automatically create a duplicate node. That's just the small things that make life a little bit easier. So what's that do for us? Once we have this list of all the points, everything that's on the far left side, everything that's on the bottom right side, or the far left and the bottom side, how do we identify what's the first point and the last point for this line to be created? So we're evaluating now the point.y value, and we're taking this in, which is a messy list. There's no real order to it, and we're sorting it by the key for the y. And what this will do is it will take that unorganized list and reshuffle it so that anything with the smallest y value is at the first. So the key that's the smallest will move the point that's the smallest to that same location. And this list.sortByKeys node is really helpful when you have this unstructured set of data, but there's a logic that we can extract like this, where if I have all of these points, I just have a collection of points, but I want to order them based on what's closest to the restroom or based on what's closest to this intersection of columns. You can use this list.sortByKey to really help manipulate that. So you create a list of 11 points now. Once I have that list of 11 points, I can say to isolate just the first item in that list, and isolate the last item in that list, and create a basic line that connects them by that start point and that end point. And that start and end point becomes really helpful because if you remember early on, we said we need a line that our dimension string is going to anchor to. So you'll see that that line directly out of here becomes your input for the dimension string here. So what's really going on up here, because we're kind of jumping back and forth, a few things are happening. Stupid mouse. I'm getting the active view from the model because I know that I want to place this in my specific floor plan view. So if I was in, for example, a section view or the level 2 floor plan that I wanted to dimension, it's going to pull whatever your active view is open. Or you can specify it. That's a good point. So it's going to find from the current document the active view, and it's going to place those dimension strings in the active view. Daniel's point was you can also go to the, I think it's the view options here, where you can specify exactly which viewport you want it to set to. So I just searched for view and I identified the selection view, where you can choose, I guess we have 3 different entry-level floor plans, but if these were more specifically named, you can see that use case. So I'm just going to go back to my first floor view for when I ran this. And now you can actually see that that dimension string populated again. So this goes back to what we were saying about running multiple times the same Dynamo script. And it's thinking on how to make it smaller. So you can see now I've run this script, but there's also this old vestige from the first time I ran it. So you want to be a little bit careful when you're working back and forth with Dynamo scripts because it will do that. It's not a big deal if it's a dimension string, but it's a big deal if it's a column. All right, so the other things that we're looking at here is we're getting that active view. We're placing the dimension. So the node here, if I just do a quick search for dimension, you'll see you have the ability to create by elements. And so if your input here was, instead of a grid line, it was maybe the reference element for the insertion point of a chair, whatever your use case is, or maybe it's the endpoint of a table, or the bounding box of something or other. That's how you can start to really change out what this is oriented toward, is changing it this reference element. In our case, we have that reference element looking at the grid lines. But how do we differentiate between what's a horizontal grid in this list and what's a vertical grid? We have no real ability to do that. So we have to compare maybe the vectors. So lines are really interesting, right? You have a start point and you have an end point, and then the actual line between them. But then there's a vector orientation of that line. And what the vector.isParallel node allows us to do is identify that vector and compare whether or not this grid line is aligned to that vector. And again, this goes back upstream where we see a vector by 2 points. We're isolating the start point and end point of all these curves and creating these vectors just to check if they're parallel later on. And then again, this gives us a Boolean mask that we can get a yes, no, or a true, false value for, which can then be filtered appropriately. So that's really the depth of what's happening here. Again, you guys weren't probably able to follow along very well, but at least we talked through the logic about working upstream and downstream. And I guess I should have probably had a better node best practice here where I named this like grid vectors or something like that, and pulling that all the way from up above so we know what it is that we're working with later on. Any other questions that this has brought up? Red flags?
I noticed you had somewhere else in there, you had the same variable listed twice. You can do that?
Yeah, so do you know specifically what part?
I don't remember where. Oh, right there. The point list. It's listed twice.
Yes.
Yeah, so it's twice. So there's not a problem using the same thing twice.
That would be correct. And so there is the ability to define global variables in these code blocks. And code blocks are cool too because I can do like 1 plus 1. And I can run that mathematical formula inside of there. And these can actually get to be really complicated, where in addition to doing 1 plus 1, I could also use this code block to say elements. So like, let's do elements dot set parameter by type or instance. And then I can start to specifically write those code blocks. So the same things that you're seeing with the nodes, point.x, point.y, you can type all those things into these code blocks and really compress your scripts to be very small. The reason that's a bad practice is because someone who doesn't know code blocks is going to open this up and they're going to be screwed because they're not going to know what or how to fix this. So I like to work with code blocks all the time, especially if, for example, I know I've tested this script 20 times. I know it's not going to break. I can hand it to someone who's not going to be able to break it by using a code block. So they can't accidentally, I'm troubleshoot this and move something around incorrectly.
Gotcha.
So code blocks are really good for that. Inside those code blocks, you can define a global variable. But what this is doing is defining just something local to this list.
Yeah, I noticed you're grabbing it from the same source and just putting it 2 different places.
Exactly.
But since you defined those variables, I wasn't sure if it... Oh, wait, no, there's the one that says point list and point list 2.
I just changed it to say
change
point
it.
list 2.
Okay.
And you'll see what happens when you change the name is it disconnects from what was feeding it initially. And so, for example, well, what if I wanted to just use point list again, right? I've declared that variable. It's going to ask you to provide it another input because this isn't a global variable. It's just something that you can use inside of this value here. So if I wanted to then take point list and add 1 to it, whatever that use case is. So it's just local to this specific code block.
Gotcha.
Yeah, I love code blocks. They're really, really, really powerful. Any other questions?
So the line you created, is that actual geometry in Revit? Or is that just a reference that's not really geometry?
Yeah, so that's a great question that came up a lot in different ways. Well, why isn't my column showing up in this last definition that we created? Why don't I see a tiny column here? That column is being placed in the Revit model. The line is living inside of the Grasshopper environment. So you're not baking for Grasshopper, to steal Grasshopper's language, you're not baking that line into the model environment. You can, however, take a model curve and create a model curve, but you have to specifically direct Revit to create a model curve from a curve. And then it will produce a model curve inside of the model environment. So now if I were to run this script, that model curve should create that rhetorical baking process. You can see that by it generates its ID, and then when I come down here, I'll see that model curve. So that model curve is now placed in the environment.
And if you run that multiple times, it creates that multiple times.
Mm-hmm. And so one of the use cases that I actually find really helpful, and this is going to be more on the hyper advanced form finding shenanigans side of things, which is always fun to talk about. I have I found this example to be so helpful so many times, where how do you place an adaptive component in a model? So I'm going to open this up in Revit 2019. This was a demo that we developed for some other training curriculums that are really advanced, focusing on adaptive components. I'm going to show how we were working with it in Dynamo, just because one really helpful best practice is how do you take a model curve that maybe your design director or your project manager has worked with, and how do you bring that into Dynamo so your technologist can maybe renumber all the rooms in a project, like a hospital or a hotel, based on a coherent logic that's actually representative of the end result. Because that's probably one of the most frequently done tasks that can be easily automated. So if we ignore what's going on in the background, which is just kind of like a ceiling view of this crazy surface is a bunch of adaptive components that have been placed based on a UV grid from Revit, a UV grid from Grasshopper. We basically brought a surface in, analyzed that surface, and identified an adaptive component to map to that surface. Cool stuff, but not really the point of what I was trying to share. is there's, maybe I'll change even this background so we're not seeing.
So you generated that adaptive component manually in Revit?
So we built the adaptive component. So I can edit the family itself. And then when you have that adaptive component placed, you load it in the project. In just the same way how we can create a dimension string, you can insert an adaptive component by points. And that allows you to start to manipulate some of this stuff. Again, not the point, though it's very interesting. For practical reasons, I wanted to be able to renumber. This is room number 200, 201, 202, 203, 204, etc. Well, typically when you're modeling this, you're just placing these rooms fairly irrationally. However, you can have someone who might know that room numbering logic and have them build a model curve. So then what we're able to do is take that model curve. I can't remember if this was a 2.0 or 1.3 script, so I could be regretting my own decision here in a second. But we want to bring that model curve into the Dynamo environment. And I haven't really graphed this up or noted it up for anyone else's use. But for the sake of the demo, you have the ability to select model elements. So rather than using that category collector that you see a few nodes below, you can actually specify individual elements that you want to manipulate. In this case, I want to consume that design director's curve, whatever it is. Maybe they sculpted some form, don't really care. I can click on select here and you'll see it becomes grayed out. And then I can go to the model environment and I can select that actual curve. And now you're seeing that element ID show up. I can evaluate that element and subdivide it into smaller points. Again, you can see I'm taking that element geometry, evaluating it at intervals, and then I'm checking to see, are these points inside of my room elements? And then I'm doing some fancy mapping of the lists to, again, resort using those keys, and then to drive the room number so that it is, in fact, room 200, room 201, room 202. These are the really practical uses for applied automation that will just make design much more fluid because we don't have to focus on the BS of production. Yeah, questions? That might be a good place to end it. I don't know how long we were supposed to go, but thank you guys for staying this long as is. And again, thanks to Paige for hosting us and setting all this up and bringing together Rhombus and the Denver Dynamo user group. So, thank you guys.
That's great.